Is my screen visible to everyone in the full mode? Just confirm it.
Yes.
Okay.
Yes, sir.
Yes, sir.
So today our topic is the recurrence relations. So I think it will be good if you interact in the classrooms, like the offline classrooms. If you have any problem, you can ask your doubts. So today our topic is the recurrence relation. So first of all, what is the recurrence relations? So recurrence generally means, so it have a patterns like so obviously series is connected there or the sequence is connected there. So it is a sequential relations where the terms of the sequence are related by some relation. Like if I say that a sequence is an, so in this sequence n will varies from where? From 0, 1, 2 and up to infinity, n will continue. And in this an, so if you take the terms are like a0, then next term is what? a1, then a2, then a3, and then this way you will get. So it's n minus 1th term will be n minus 1, nth term, that is an, and after that you will get an plus 1, and then you will continue like this. So now if we take some relation between this general expression of the sequence like that, suppose 2an is equal to some a of n minus 1 and plus 3 into a of n minus 2, then you can see that this is a relation between the sequence terms, and this type of relation is called the recurrence relations, that a relations which involve some term from the sequence like suppose if I say that in a particular region the populations, if I count the populations in a particular region, suppose in 2030 the or 2000, suppose if I take the past season 2015, suppose the population is 1 lakh in a particular region, and then suppose in the 2016 that the population is 1 lakh and suppose 350, so there is an increment of 350 there. And then so we can, if we have one relation like this in the consecutive years, if we take the nth year and the n minus 1th year and the n minus 2th year, and if there is a relation like that, that the increment in the nth year than the n minus 1th year just thrice of the increment in the n minus 1th year than the n minus 2th year. So that we have built one relation that the increment in the populations in the nth year than the n minus 1th year just the thrice of the increment in the relation than the n minus 1th year than the n minus 2th year. That means from that relations you can build one recurrence relation like that. Suppose if you take the t of n minus t of n minus 1, that is equal to 3 into t of n minus 1 and minus 3 into t of n minus 2. If you take it in the left hand side, you will get tn, then minus 4t of n minus 1 and plus 3t of n minus 2 is equal to 0. Now you can see that this is a relation in the sequence tn where the initial value can be taken as at the 2015 it is t0 and in the subsequent year it is t1. So now you know t0, you know t1, and you know one relation between 3 subsequent years. There may be 4 years or 5 years relation also. So now from these relations, if you want to build a solution of that relation, that means if you want to find a tn which is a function of n, that means function of this variable, where by putting the values n you can calculate the population or you can predict the population in any year. That means if I want to predict the populations, if the population goes like this pattern what is the population in 2000, suppose T 2030 or T 2035, what is the population in that year? If I want to calculate, if I want to predict it, so we need to solve this relation. This actually relation you can build from any 3 or 4 years observations, that how the patterns change. Suppose if from this year to the next year the population is twice than the previous years, then you can build such type of actually relations. But the major thing here, it is to calculating the solutions of this recurrence relation, how to solve and how to prepare a solution which fits for any n which is greater than that values 1, so that we can predict it up to the infinity. So that means
স্যার এটার মানেটা কি যে একটা টার্মের সাথে তার আগের দুটো টার্মে একটা কোনোভাবে রিলেশন বের করতে হবে, এটাই কথা?
একদম, মানে আমরা we want to calculate the general solution, that means আগের টার্মের রিলেশনটা তুমি পাবে। Suppose if I take that Tn and Tn minus 1, so suppose the population in the 2021, that is suppose you are taking as Tn. Suppose population in 2022 you are taking is as suppose what, so 20, suppose it is T of n minus what 1 then, and population in 2019 suppose it is T of n minus 2. So then you can calculate the population changes in this duration, so that is Tn minus what, Tn minus 1, and population changes from 2020 to 2019, 19 to 20 actually. So now you can build one relation that how the population change. It may change in the linear pattern, it may change in the exponential pattern or any other non-linear pattern also. But if I take the linear pattern like here, that the population change in the Tn to Tn minus 1 is thrice, यानी कि 3 गुण है यहाँ पर, thrice of the T of n minus 1 than the T of n minus 2. तो ये तो relation आ गया. So now from this relation we want to build one Tn expression which actually is a function of n, like maybe that 3 of n square minus 4n plus 1, or maybe 2 into 2 to the power n plus 3, like that. We want to find that relation from where we can put any values of n and you can predict the population in any years, any subsequent years. That means if you want to just take the population in the 2025, you can do that. If you want to calculate 2030, you can do that, just put the values in there and you will get the values. That means we have some initial values, the initial values means the known values, and we have a relation between the years, subsequent years, that means the sequence terms. Then we will build a relation, then we solve that relations to find the solution like that, and from that solution you can predict the population or the term in any values of n which is greater than 1. Okay, that means recurrence relation is nothing, it is just a relation between the sequence terms, nothing. So sequence term जो है general term जो होता है कि n-1 term, n-2 term, nth term, उसके ऊपर एक relation है, तो ये not restricted to n-2, it may be there n-3, maybe there n-4, and according to that there will be some classification of the recurrence relations, and now we will discuss that. So that is the actually need of that things. So now as we progress you will understood the remaining things. So there are some classification of the recurrence relation. So if we say classification, so classification means there are two types obviously. First of all is what, linear, and second is what, non-linear. So what is linear terms? So linear term means only this type of an minus 2 or tn minus 2, this type of things are there. No square type, cube type expression, e to the power type expression will be there. That means if I give some relations in the linear, so it will be suppose T of n minus 1 or suppose plus 3 into T of n minus 2 is equal to suppose T of n. So this is a linear relations. Or if I give a general expression, so it will be T of n will be suppose some k1, so k1 is a constant, k1 into t of n minus 1 plus some k2 into t of n minus 2 and plus k3 into t of n minus 3 and like that. It may continue up to any term, maybe up to kth term or any other terms. So these are all of linear expressions. So you will not get any square type expression or cube type expression here. So all the sequence terms present is in on the first order, on the first degree actually. Every terms is in the first degree. But if you take the non-linear term, so non-linear term it will looks like suppose 3 into t of n minus 1 to the power 3 plus 2 into t of n minus 2 to the power 2, like this term, or suppose 3, or suppose t of 4 t of n square plus suppose some 6 t of n minus 1 plus 2 t of n minus 2 is equal to 0, like this type of expression. So where you will get some cubic expression or maybe some e to the power over t of n minus 1 also. So this is the basic difference between linear and non-linear. In the linear you will get all the terms is of like the differential equations. If you take this as a some derivative dy dx type, if it is only in the first degree, so it is a linear term. If it have more than degree 1, then it is a non-linear terms. Is it clear?
Yes, sir.
So
Yes, sir.
in the linear also there are two types of pattern. So one is homogeneous and another is the non-homogeneous. Non-homogeneous. So what is homogeneous pattern? So homogeneous means there will be each of degree 1. That means here you can see that it is of degree 1, it is of degree 1, it is of degree 1, and each of degree 1. Suppose if I take another expression here like this, suppose it is 1 minute, I can erase that, like t of n is equal to t of n minus 2 and plus suppose 3. Now you can see that this is also a linear term, na? There is no higher order expression. Is there any higher order expression, higher degree expression? Nothing. So it
No,
is
sir.
of degree 1. So that is a linear expression also, but you can see that this 3 corresponding to that 3 there is no terms tn here. So that means it have a degree 0 term, na? Nothing is there. So this type of expression is called the non-homogeneous type. So if I take this, so this is a non-homogeneous type. So Tn is equal to T of n minus 2 plus 3, or suppose T of n minus 4 T of n minus 1 and plus 3, that is equal to 0, or plus 12 is equal to 0. All these type of expression, or suppose T of n minus 4 is equal to 0, all these type of expression are actually the non-homogeneous expression. Here homogeneity break here, because homogeneity, if you just remember the homogeneous expression, the function which is homogeneous is actually f of ck. This type of expression is equal to c into what? F of k, na? Or if you take the x variable here, cx is equal to c into f of x. If it is in the two variable, then f of cx cy, this is equal to, or c1x c2y कर दो यहाँ पर, c of x c of y, it will be some function of there will be c to the power n into what? F of xy expression. So this type of term is actually we call the homogeneous expression, where you can take this cn outside, but from here if you put like this, you can't take anything from that 3 because there will be no c. So that's why if you have this type of constant term alone in the linear expressions of the recurrence relation, so these are classified as the non-homogeneous linear recurrence relation, and these all other things are the homogeneous type. That means all of these things, the number 1, it is T of n minus 1 is equal to 4 T of n plus 3 T of n minus 2, or maybe T of n plus 2 T n minus 1 plus 6 T of n minus 2 is equal to 0. So all of these are the homogeneous type of expression, because only you can see that there are term of degree 1. Okay, So is this classification clear to everyone? Homogeneous and non-homogeneous?
Yes, sir.
Okay.
Yes, sir.
So now we are going to solve that. In the solutions in the syllabus, you have only linear homogeneous type solution. So now the heading is the solution of linear homogeneous recurrence relation with constant coefficient. That is very important, with constant coefficient. So actually these have a very close attachment with the differential equation. So all these things actually are like the solution of differential equations. You have also seen this type of solution, na? The solutions of the second order ordinary differential equations with the constant coefficient by using the characteristics method, na? If a second order differential equation is given, suppose d2y dx2 plus 4 into dy dx and plus 3y is equal to 0, then you build the auxiliary equations, na? M square plus 4m plus 3 is equal to 0, and then you find the roots of the auxiliary equation, and it will build the e to the power first root m1x plus then the c1 and c2 e to the power m2 of x. This is the solution. Can you remember that solution of the second order ODE?
Yes,
So
Yes,
here
sir.
also the recurrence relation are like the same thing. If it is a constant coefficient linear homogeneous recurrence relation, you can solve it by the characteristic root method, and the solution is like the same as the ODE solutions. So here the method is first method. By we will discuss the first method is the characteristic root method. Characteristic root method. So this first method is like the ODE method. So here what we do, we will take one problem and we will solve it. So first of all, let the problem is like the if I take the problem as using characteristic root, method, find the solution of the recurrence relation, find the solution of the recurrence relation and suppose the recurrent relation is an is equal to 2an minus 1 plus 3a of n minus 2, and subject to the initial condition, and the initial condition is a0 is equal to 1, that means the initial term is 1 and the next term is 2, and hence find a of 7. Okay, calculate it. That means first of all we will solve that by using the characteristic root method, and then we will find a7. You can calculate anything, not only for the a7, you can calculate a100, a200, a1000, 2000, anything. So that is the process. So now how to solve it? So first of all, first thing, take everything in the left hand side and arrange it in the order. But take everything in the left hand side and arrange it in the order of the sequence. Like if your function is an is equal to 2n minus 1 plus 3 of n minus 2. Sometimes in your question you may see n minus 1 in the left hand side, n minus 2 in the right hand, or anything in the shuffling order. So first of all you have to arrange it like that. An minus you will get 2a of n minus 1 and minus 3a of n minus 2 is equal to 0. So everything should be in the proper actually sequence. That means first you will get the highest term an, then there will be the n minus 1, then n minus 2 in this order. Is it clear?
Yes, sir.
Everything. So in the proper order. After that, what you have to do? You have to find the characteristic root. So now characteristic equation is, so like the differential equation, first term is m square. So here we will put it as the x square. So it is the x square minus second term is 2 into this is x and minus this is 3 is equal to 0. That is the characteristics equation. Now suppose you have one relation like that, an is equal to simply 3a of n minus 2. No n minus 1 term is there. That means here also you have to take everything in the left hand side. So it will be an minus 3 into a n minus 2 is equal to 0. Then you have to complete the series. Complete the series means you have to give the n minus 1 also there. So an minus coefficient is 0 into what? A n minus 1 minus 3 into a n minus 2, that is equal to 0. Then you can build the characteristic equation, and which is x square minus, so there will be no term, that means 0 into x, and minus you will only get 3 is equal to 0. Is it clear?
Sir, characteristic equation টা আরেকবার বলুন না।
In the characteristic equation, in the first term you have to put the, so how much it is of order 2 na. So if I build the order, how to determine the order of the characteristic equation, so just in the previous page, here we can also say the order things. So order of recurrence relation is k if the recurrence relation is like that. That means an is equal to some c1 into a n minus 1 plus c2 into a n minus 2, and in this way if you have ck into a of n minus k, so then we say that it is a recurrence relation of order k. So here order k means the least term present here. So in this equation you can say it is of order 2, it is of order 2, it is of order what? 3, because here t of n minus 3 is there. So if you see it, it is of order 2, it is of order what? 1, because the lowest term is t of n minus 1. So here also in this equation the lowest order is what? 2, here is the lowest 2 n minus 2. So that means what you have to do, like if it is a differential equations, so then it is the second term, that means d2y dx2, it is the 1 degree term dy dx, and it is the general term y. So in that case what we put? We put m square here, we put m for dy dx, and we put 1 for only y na. That is the process. So here also we put x square for n, x for a n minus 1, that means just replace the a n by x square, just replace the a n minus 1 by x, and just replace the a n minus 2 by what? 1, nothing else. So first of all rearrange the equations by taking everything in the left hand side, सारे को सारे टर्म को लेफ्ट हैंड साइड में ले जाओ, देन उसको सीक्वेंस में अरेंज करो. तो पहले n आएगा तो उसके बाद क्या आएगा? n माइनस 1 ही आएगा, उसके बाद n माइनस 2 आएगा. अगर टर्म मिसिंग भी है तब भी उसको कंप्लीट करना है कोएफिशिएंट को 0 देकर. जैसे यहाँ पर है, देखो टर्म मिसिंग है तो n है, उसके बाद n माइनस 2 है, n माइनस 1 नहीं है. सो देन यू हैव टू टेक द n माइनस 1 ऑल्सो देयर. इसलिए हमने देखो 0 इंटू n माइनस 1 दिया है. तो इसके बाद क्या करना है? कुछ नहीं. तो यहाँ पर सिंपली क्या पुट करना है? एक्स स्क्वायर. यहाँ पर क्या पुट करना है? x, और यहाँ पर क्या पुट करना है? 1. तो पुट कर दो. तो एक्स स्क्वायर हो गया, ये 0 इंटू एक्स हो गया, इसलिए इसको गायब कर दिया. नहीं है यहाँ पर. तो ये 3 इंटू 1 हो गया, 3 इज इक्वल टू 0. नाउ इज इट क्लियर?
Yes, sir.
Okay, so we will take 1 or 2 more problems on that. So before that we will solve that. So it is the characteristic equation. Now just solve it by using the middle term factorization. So what are the terms? X minus 3 into x plus 1 na is equal to 0. So x equal to 3 is one characteristic root and x equal to minus 1 is another. So these are the characteristic root. These are the characteristic root. Now the solution of the recurrence relation is solution of the recurrence relation. Okay, this is another problem. Okay, this is actually don't make it like that. I think it will be, this is extra. And then solution of the recurrence relation is, so here is a pattern of writing the relations. So here your an will be general term an, general solution will be some constant a, just like the differential solution, nothing else, some constant a, then first characteristic root to the power n plus some b into second characteristic root to the power n. That is the solution. That means it is the first characteristic root, it is the second. So you can take it as minus 1 here and 3 here, it will not change your solutions. That is the way of building the recurrence relation. So if the roots are distinct, so characteristic roots are what? Distinct. So if the characteristic roots are distinct, then your solution will be, so if the roots of the characteristic equation are distinct, means different, like suppose k1 and k2, k1 and what? K2, suppose, then solution is an is equal to some constant a into that root k1 to the power n plus b into k2 to the power what? N. So that is the solution pattern of the characteristic roots. Is it clear how to write the solution?
Yes, sir.
Okay, so now we will find the constant by using the initial condition. So a0 is 1 and a1 is 2. So that are given data is a0 is equal to 1 and a1 is equal to 2. So now put, now for n is equal to 0, okay, we will give it as 1. Now for n is equal to 0, from 1 we get, what we get? If you put n is equal to 0 here, you will get a0 is equal to a into 3 to the power 0 plus b into minus 1 to the power 0. That means it is a plus what? B, and a0 value is what? 1. So it is your first relation in AB. Take it as equation number 2. And then for n is equal to then 1, for n is equal to 1, what do you get? N is equal to 1, from 1 we get, what you will get? Then a1 is equal to a into 3 to the power 1 plus b into minus 1 to the power 1. So a1 value is 2, so 2 is equal to 3a minus what? B. So that is the second relation in A and B. Now solve these 2 and 3. So from 2 and 3, what you will get? Bolo? A plus B is equal to 1
equal to 3
and 3a minus b is equal to 2. That means here you will get 4a is equal to 3. So a is equal to 3 by 4, and what is b? B is equal to 1 by 4 na, 1 minus 3 by 4 is equal to 1 by 4. So that is your A and B. So the solution is, actually A of n, that is equal to, so now put the values here, A is equal to 3 by 4. So 3 by 4 into 3 to the power n plus 1 by 4 into minus 1 to the power n, minus 1 to the power n. So that is the solution, or you can also take it like that, that an is equal to 3 by 4 into 3 to the power n plus 1 by 4 into minus 1 to the power n. You can take this 1 by 4 common, and you can take this as 3 to the power n plus what, 1, and plus minus 1 to the power n, like it. So now you have to calculate what? So this is the general solution, that is your answer for the general solution. Now you have to calculate the A7. Now for A7, what you will put? Put n is equal to 7 only. You get A7 is equal to 1 by 4 into 3 to the power 7 plus 1 plus minus 1 to the power 7. That means 1 by 4 into 3 to the power 8, and minus 1 to the power 7 is minus 1. So what is the value of 3 to the power 8? Calculator. Value of 3 to the power 8. 3 to the power 8. 6561. 1 by 4 into 6561 minus 1. So 1 by 4 into 6560, 1640. Okay. So that is the value of A7, and like it you can calculate the values at any, for any values of n is equal to 100, 1000, for anything you can calculate. So that is the process of solving the recurrence relation.